Right. So it says here that it's 9.3 day 1, so we're starting a new section. We finished the inverse one last class with the composition. So starting something new today, it says solving trigonometric equation. So remember how anytime, we also spoke about the fact that your sine theta, cosine theta, tan theta, they're all nothing but functions. They're nothing but functions. F of x equals to sine theta. So when you talk about a function, you have an input and you have an output. And when you work with functions, you also have to learn how to solve an equation for that in that particular family. So that's what basically we're going to be looking at. That's why it says solving a trigonometric equation. How do you solve a particular trigonometric equation? So every time you learn a particular function, sometimes the solving becomes a little different. For example, in quadratic, if I have to solve it, I had to learn how to factor, and I had to learn or using the quadratic formula and so on and so forth. So depending on what kind of equation you're solving, you may use a certain strategy. So we're going to look in trigonometric equations, what are the different strategies we're going to use to solve it. Okay. Solving a trigonometric equation like you would solve an algebraic equation. So pretty much the same concept. So pretty much the same concept as any other algebraic equation. But again, in algebraic equation, there are so many kinds of algebraic equation, right? There's linear algebraic equation, there's quadratic, there's cubic, there's square root, there's exponential, there's log, there's all of them. So when we say algebraic, it comes under a big umbrella. Okay. So, but before we do that, it says linear type. I also want to make sure that we understand what we are solving for. So I think if it's when there is a variable involved like an x, it's easy to see what we are solving for. So for example, if I take a linear equation, I don't know, I'm just making up something. When we tell you to solve, what are you solving for? For the x, right? You're solving for x. Basically, you're trying to tell me what the value of x is. And when you solve for that x, what does it mean? It means that whatever value I get for x, when I substitute it here, my left hand side will be equal to the right hand side. So basically, I'm answering the question, what is that value of x that will make this equation a true statement? What is that value of x that will make my left hand side equal to the right hand side? Right? So even if I take a quadratic equation, let's say x squared minus 4x, I get two solutions. What do those two, why? Because it's an x squared. What do those two solutions mean? Those two solutions means that when I substitute those solutions here, my left hand side will be equal to my right hand side, in this case, which is 0. Or the way you frame the question is, what are those values of x that will make my statement a true statement? That's pretty much what we mean by solving. When we say solve and we give you an equation, we are basically asking you, what are those values of x that will make the statement true statement? Okay. Having said that, we all know this one. I'm not saying anything that you don't know already. All of us know this basic stuff. But what about in a trig equation? So I'm going to go ahead and use the first example that they've used. This is something that's really simple. Tan theta equals to 1. So you're being told to solve this. I'm just giving you a background before we actually plunge into solving. We're told to solve this. First of all, what am I solving for? What's my variable here? Theta, perfect. The right answer is theta. Theta is same as x. Remember, a lot of times we even say tan x instead of theta. So theta is my unknown. Theta is the unknown. So what am I solving for? What do you ask yourself in this statement? For what angle is tan of that angle going to be equal to 1? What value should I put here? What value should I put here so that I put that value here so that whatever I substitute here for theta, my output will be equal to 1. So what value of tan angle is equal to 1? Do I know the answer to that? When is the value of tan theta equal to 1? When is the ratio 1? We all know our unit circle, correct? It's at pi by 4. So if I say tan pi by 4 equals to 1, is that a true statement? Yes. So theta is going to be equal to. So basically that's what I'm going towards. But is that the only value? One more thing. I just want to talk about one more thing. That tells you that the interval is between 0 and 2 pi. That's important. Because remember, a circle can keep going round and round and round. So we restrict ourselves just to one unit circle. That's one thing I want to talk about. There will always be, they'll tell you that it's normally between 0 and 2 pi. The second thing is we are not looking at inverse. If I'm looking at tan inverse, that would have been restricted to first quadrant and fourth quadrant. We are not talking about inverse. We are talking about straight away the function of tan theta. That means you're looking at the entire unit circle. That means I'm looking at the entire. So which other quadrant is tangent positive 1? Quadrant 3, right? Because all students take calculus, so it's going to be 5 pi over 4. So these are my two solutions. That will be the answer to the first question. Is it sort of clear? So you're basically solving for theta, but it's not going to be as simple as that. It's not going to be as simple as that. You'll have to, there will be situations where you'll have to isolate, like for example, question number 4. You have to get the secant theta by itself before you can solve for it. You will have to get the sin theta by itself before you can solve for it. Okay. So now that I've given you some sort of an introduction as to where we are going towards, let's go ahead and fill in a couple of these blanks and then we'll start working on these. So the first strategy is isolate. And we know this from our algebraic equation. Whenever you're doing solving for x in algebra, your goal is first to isolate the x. So in this case, isolate the trig function by adding, subtracting, multiplying or dividing anything that's along with the trig function. And find the angle in radians. We always talk in terms of radians. Within the domain restriction. All of this is important. If I did not have the domain restriction, my answer will be pi by 4, 5 pi by 4. After 5 pi by 4, my coterminal angle to pi by 4 is also 9 pi by 4. Is also, so it basically goes on, right? Because I can go around the circle as many times as I want. I will not be restricted to theta equals, because there are many other angles where tan theta is equal to pi by 4, equal to 1. It's not just pi by 4 and 5 pi by 4. I restrict it to pi by 4 and 5 pi by 4 because there is domain restriction. I'm only looking for values within one unit circle. I'm only looking at one unit circle. Right, okay. So we already solved for this. Tan theta equals to 1. At what value of the angle will the tan theta equals to 1? We already talked about it. It's going to be theta equals to pi by 4 and 5 pi by 4. Everybody okay? Okay, can we all answer the next question without any input from me? When is the value of cosine theta equals to negative square root of 3 over 2? And remember, you're looking at all the four quadrants. You're looking at all the four quadrants. Can we all look at this and let me know if it seems okay to you? So basically, I asked myself, when is the value of cosine theta square root of 3 over 2? I always like to work with my first quadrant, so I just asked myself, when is the value of cosine theta square root of 3 over 2? I know it's at pi by 6 or 30 degrees, because remember cosine starts from 1 to 0. So it's at pi by 6, except I want negative. Where is cosine negative? Cosine is positive here, because all students take calculus, so it's negative here and here. Here the reference angle is 5 pi by 6, here the reference angle is 7 pi by 6. Yeah. So that's how I thought about it. But those who are kind of still looking at unit circle to get these answers, you can always use your unit circle to answer that question. Everybody okay? Alright, in case of 1 and 2, there was no isolation required because cosine theta was by itself, tan theta was by itself. That is not going to be true in question number 3 and question number 4. So let's look at question number 3. When is sin theta? Because sin theta is not by itself, your first step is to isolate the sin theta. So let's go ahead and rewrite, isolate sin theta. That means you will divide both sides by 2. Okay, so I want to see if you guys can do this without my help. Divide both sides by 2, see what you get, and then answer the question. Everybody can check the board and see if you got this. Everybody okay? Alright, let's go to 4. Same concept, except it's secant theta. So first thing is, anyway, you have to isolate. So let's go and isolate. Let's go and isolate the secant theta. There's a negative 2 there. So your first step is to remove the negative 2. 4 over negative 2 is negative 2. Everybody okay with that? Divide both sides by negative 2. Alright, at this point, on my unit circle, I have only cosine, sine and tan. So I want to rewrite this as cosine. Remember when you rewrite secant and secant to cosecant, to cosine, you will basically rewrite the ratio as a reciprocal. That's what you should keep in mind, because it's the ratio that you write the reciprocal of. Adjacent over hypotenuse is hypotenuse over adjacent. It's the reciprocal. So you will keep this side the same, except the ratio will be written as a reciprocal. So negative 1 over 2. Negative. Then you ask yourself a question. Now you're back to familiar ground. You ask yourself a question. In my unit circle, when is the value of cosine theta negative half? Alright, there are 4 problems in this page. These are basically, I don't know if I mentioned it right in the beginning, we are going to break up our solving trig into different kinds. This is of the linear type, so this is a little more straightforward. It's like solving for a linear equation, which is fairly straightforward. You're just isolating the x. Unlike solving an algebraic equation, which is a quadratic, where you have to factor and stuff like that. So this is a little more straightforward compared to what we'll see in the next page. So let's go ahead and do all 4 of them without any help from me. I will just put up the final answer. I'll give you guys about a couple of minutes for each one of them. Thank you. Alright, and if you're still not sure, please raise your hand. I will be glad to come by and help you. Okay, let's take a look at 5. I rewrote it as a tan theta, but obviously that's not the only way to do it. You could have kept it as cotangent theta and work from your unit circle. So let's go ahead and see if you got that right. Yeah. Okay. Do the same thing for the others. I'll keep putting up the work every few minutes. And if you have any questions, please let me know. how many values of theta do we get? Only one. So this one will be only one. Normally, a lot of times quadrantal angle you get only one solution because it is 0, 1, 0, and then it's a negative 1 here. So it's only 1 at pi by 2. Because if they had asked for 0, they would have had 0 and pi, but since it is 1, the opposite side is negative 1, it's only one angle. Alright. I'll put up 7 and 8 in another minute or so. So this one is positive angle, so that's why it's quadrant 1, and sine is positive in quadrant 2, so that's why it's pi by 3 reference angles for quadrant 1 and quadrant 2. And let's go and do the last one on this page. All right, take a look at 8 or 7 and 8. So I have secant theta, which I rewrote as cosine theta, and then it's positive, so cosine is positive in quadrant 1. That's why I've also shown this here, and quadrant 4. So it kind of helps to remember which quadrants it's positive in. That way you're not running your eye on all the 4 quadrants. Yes?
I'm a little confused on how to get the other angle.
Okay. In this one, for example, or tell me which problem?
In general.
In general, okay. So let's talk about 8. Okay. So your goal is to get secant theta by itself. You got that part.
Yeah.
Yeah. Okay. And then because I like to work with sine cosine. I rewrite this as cosine theta. Yeah. You got that part also. Then you ask yourself, when is the value of cosine theta on my unit circle equal to square root of 3 over 2? So I know that cosine theta is square root of 3 over 2 at pi by 6. Okay, but the thing is, there are 2 quadrants where it's going to be positive. So there are 2 quadrants where it's positive square root of 3 over 2 and 2 quadrants where it's negative. So you want to look at both the quadrants where it's positive. So it's pi by 6, and where else is cosine positive? All students take calculus. So this quadrant also. So that's why it's pi by 6 here, as well as the reference angle for this is 11 pi by 6.
Okay, so you're just looking for the spot where it's the same thing again.
Exactly. So let me show you one with a negative, for example. So here it says, where is tan theta negative square root of 3? So I know tan theta is positive square root of 3 at pi by 3. But this is not what you want. You want the reference angle of pi by 3 where it's negative. So tan is all students take. So tan is positive here also. But you don't want this. You want this and this. Because it's negative. So the reference angle for pi by 3 is 2 pi by 3. And the reference angle for pi by 3 in quadrant 4, because negative here, is 5 pi by 3. So that's way low. Yeah? Okay. So like I said, that's why it helps to know which ones are positive and which ones are negative. Sure. Okay, that was a good question. Any other questions? All right, going on to the next page then, if nobody has questions, anybody? So continuation of the same thing, except, like I said, we're talking about solving a trigonometric equation. Trigonometric equation is not always in a linear form. It could be in the quadratic form, and that's what we're going to do right now. We're going to learn to solve a trigonometric equation which is written in the quadratic form. It says use a okay. Let's just look at the quadratic equation before I make you guys fill in the notes. It says the same thing. So we are looking at solve each equation over this interval. So we are still looking to find all the answers within one unit circle. And what do you notice here? Sine square theta minus 1 equals to 0. Quadratic equation. 2 cosine square theta equals to cosine theta. Quadratic equation. They are not linear. Why? Because my x, this is my unknown, is squared. It is squared. How do we generally solve a quadratic equation? We try to factor, is one thing that we try to do, and I think pretty much on this we're going to try to do that. We're going to try to factor this and get two linear equations, and then we're going to do that. But talking about factoring, I think all of us, I could make out that we were all comfortable with factoring a trigonometric equation when we learned factoring a trigonometric equation, and we do not have to substitute. We can straight away factor this. So for example, let's look at this. Let's look at the first one. Sine square theta minus 1 equals to 0. This is a quadratic equation because the sine is squared. When we talk about factoring, we generally look for what kind of factoring I want to do. Meaning we look for the pattern. Is it a trinomial factoring where I find factors of C that add up to B? Is it difference of square, or am I just doing GCF? What pattern do you think you'll be following here? Sine square theta minus 1 is difference of square. Perfect. Perfect square, perfect square. So my two factors are, can we all write down the two factors? I want to see how we are doing with the factoring. Because we did do factoring in a couple of units back, so I want to make sure that we remember how to factor. So what are the factors of sine square theta minus 1? The reason I'm even asking this is I think I'm trying to get a feel of do we need to substitute? Okay, let me write this down. So if I'm trying to factor sine square theta minus 1, I know it's difference of square. This is a square minus b square. Factors of a square minus b square is a minus b, a plus b. So my factors are sine theta minus 1, sine theta plus 1. Everybody got that? Okay. I think my thing is everybody comfortable with this, or do we all need to do substitute, or at least some of us may? Is it more comfortable? Are we more comfortable if we substitute? If I say sine theta equals to x, and what am I factoring? X squared minus 1. Is it easier to factor this, or are we all comfortable factoring just this? Are we able to recognize that we can factor this because it's a quadratic and perfect square, sine theta minus 1, sine theta plus 1. Okay, just for this one I'm going to show you where I'm substituting, and going forward you can decide, is it easier for me to factor by substituting or just straight away factoring. So if I substitute sine theta equals to x, this becomes x square minus 1. Factors of x square minus 1 is x plus 1, x minus 1. But remember, you have to substitute it back. So x is sine theta, so sine theta plus 1, sine theta minus 1. So you are back to the same, except if it is harder for you to recognize the string to factor, go ahead and substitute with any variable, either x or a or b, or this could have been a square minus 1 or whatever. All right, that's all I'm trying to figure out. That do the factoring in any which way that you feel comfortable. Either do it directly if you can recognize the pattern, or substitute with an x, and which gives you an equation that you recognize, because we have obviously learned factoring with x's and y's, right? Okay, so going back. So sine square theta minus 1 is factored as sine theta minus 1 and sine theta plus 1 equals to 0. Everybody good so far? Okay, I'm going to jump back up and fill in these notes, and maybe we can read the notes as we do the work. So it says use a temporary variable, and this is what I was talking about. Use x if you need to. That's why I'm going to add. You don't have to. If you need to make your factoring simpler, you can do that. If there are common terms or a quadratic, then basically they're saying do the GCF if you need to. Use that. Remember, always look for the common factor. That's always the case in any factoring. GCF should be the first thing you should be looking for. Once you factor, how do you solve? You use a zero product property. You know all of this, I'm just putting it down. Find the angle in the radian mode within the domain. Okay, I'll write it down and then we'll talk about it as we solve it. There may be extraneous solutions. And we'll talk about this also. All right, let's go ahead and do this. So whenever you're factoring and you get the two factors and you're supposed to solve, what do? You use the zero problem, meaning you say, going back. Okay, I'm just going to go back for now just to show you what we're talking about. So if I had this, forget if you had this. If it was x squared minus 1 equals to 0, you factor it as x minus 1, x plus 1 equals to 0. Everybody good? And how do you solve for the values of x? You set each of them equal to, you guys remember? And this is called as your zero product property. If two things are multiplied, they're equal to 0, that means each of them is equal to 0. That means my values of x is equal to 1. We good? Right? Okay. I'm going to jump back to, I'm trying to get us to work without really substituting. The reason is because I think substitution just has so many more steps and then we have to remember in the end to substitute it back. So if you can do the factoring without substitution, great. If you cannot, that's fine. Just substitute. So in this case, I'm going to do the same thing. Set each of them to 0. So sine theta minus 1 equals to 0. Sine theta plus 1 equals to 0. Everybody good? Same thing as any other factoring. Setting each one of them to 0 because of the zero product property. And then what do I have? What is my value of sine theta from the first equation? Everybody good? And what's my second solution? So normally I would have said x equals to 1 and x equals to negative 1. And I would have, my work would have been over if I was working just with x. Everybody good? But I'm not working just with x, I'm working with sine theta, and my goal is to say theta equals to something. So you will now treat each of them as a linear equation. When is the value of sine theta equal to 1? Pi by 2, right? Because it goes from 0 to 1. Remember your unit circle? It goes from 0 to 1, comes back to 0, and when is the value of sine theta? Negative 1. So those are my two solutions. So you will basically land up with two equations, two linear equations when you factor, and you will solve each of them for theta. That's the difference between linear and here. Is everybody clear? Okay, awesome. Let's look at 2. Because it's a quadratic, let's take everything to one. Let's write it as a standard form. That means take everything to one side. We're going to try factoring. Let's take everything to one side and 0 on the other side and see how we go with it. Do we know how to factor this? What pattern are we looking at? Perfect, yeah. It is the only thing I can because there's no greater, it's not difference of square because it's not a perfect square, 2 is not perfect square. The only thing I can see is both the terms have a common term cosine theta. Both the terms have a common term cosine theta. So we'll do GCF in this case. So pull out cosine theta, rewrite it and see what's the next, what's the other equation. So please do GCF. Everybody okay? And please ask me if it's not clear. Now what are you going to do? Now what are you going to do? You're going to set each of, there are two equations just like here, right? I have two of them. Set each of them equal to 0. Each of them will be set to, each of them will be set to 0. Each of them will be set to 0. Can we all do that? The next step, set each of them equal to 0 and solve it. I want to see if we can do this without my help. Set each equation to 0 and then solve for theta at that point. So basically you're doing the zero product property. If both of them are equal to 0, one of them has to be, one or both have to be equal to 0. Okay, so I've got 1/2 of my solution. When is cosine theta equals to 0? Remember, cosine theta goes from 1 to 0. So it's pi by 2 and opposite of pi by 2 is 3 pi by 2. Okay, now solve the second one. Second one is like solving a linear equation where you have to get cosine theta by itself. Its cosine theta is not isolated. So you have to isolate it, get it by itself, and then solve for theta. How's everybody doing? If 2 cosine theta minus 1 equals to 0, that means cosine theta equals to half. Everybody good with that? And then you ask yourself a question, when is cosine theta equal to half? It's positive half, so you won't need two quadrants where it's going to be positive. Cosine theta is half at pi by 3, but cosine theta is also positive in quadrant 4. All students take calculus. So the reference angle of pi by 3 in this quadrant is what? 2 pi by 3, 5 pi by 3. So my answer for this section is theta equals pi by 3, because remember it's positive. It's pi by 3 as well as 5 pi by 3. So I have 4 solutions for this one. Alright, please let me know if any of this is not clear. We're going to do 4 and then jump back to 3 because 4 is very similar to, sort of similar to 2. At least as far as factoring is concerned. So let's do 4 and then we'll come back to 3. 3, 2, 5, 6, they're all trinomial factoring. So we'll do all of that. Whereas 4 is GCF again, if you haven't already figured it out. This really doesn't look like a quadratic. I'm not seeing a square, but you do have two terms multiplied to each other. And you can still factor. You can take out the GCF. Set each of them to 0, solve for each one of them, and finish it up. All right, take a look at number 4. You will again get theta equals to 0, and that is an extraneous solution because I already have 0 here, so you don't need to rewrite it. Basically, you're saying 0 and pi will satisfy my equation. Okay, I'm going to leave this up to see if you guys understood. Please ask me questions if you're not sure. I'm going to number the steps so you can ask me questions. All right, steps are numbered. Please ask me questions. All right, how's everybody doing with question number 4? Can I go to 5? Does anybody need another 30 seconds, minute on number 4? No? All right. Let's jump to 3 then. I said 5, sorry, I meant 3. We are going back to 3. If you look at 3, you can notice that it is a quadratic. And whenever you look at a quadratic and you try to factor, you try to look for what kind of factoring am I doing. Yes? So what do you guys think about this one? This is a trinomial, right? This is the one which has got 3 terms and the leading coefficient is 1. So you try to see what are the factors of -2 that add up to -1. Can we do the factoring of the trinomial without having to substitute? You're going to use the same concept. How do you factor something with where the trinomial? Or -5 or whatever. What are the factors of -5 that add up to? So it's the same thing, right? What are the factors of C that add up to B? Same concept. You see 3 terms. What are the factors of -2 that add up to what? What's the coefficient of x here? What's the coefficient of secant theta here? Yes, no, maybe? Are we getting what we're talking about? What are the factors of -2 that add up to? -1, right? Yes, everybody got it? So what are the factors of -2 that add up to -1? -2 +1 works. -2 times +1 is -2. -2 plus 1 is -1. Everybody good? Okay, I'm kind of not being able to judge the class. Are we okay with the factoring? Yes? Okay, awesome. All right, so let's go ahead and write this as 2 factors, as -2 and +1. So instead of x, all you're doing is writing it as secant theta. So secant theta minus 2 secant theta plus 1 equals to 0. Sorry, this is plus 1. I know there's a little bit of scribbling going on. This is plus 1. How do I know I'm correct? Remember, whenever you write factors, if you multiply it out, you should get back. Negative 2 times positive 1 is negative 2. And then if you do the middle term, you should get negative 1. Okay. Now you know what to do. You just have to do the zero product property, set each of them equal to 0, and solve for it and give me the theta values. It's secant theta, so you'll rewrite it as cosine. Okay, again, please stay ahead of me. I'm going to go ahead and put down the work, but I'm staggering it so that you will do the work before me. Okay, very good so far. I rewrote it as cosine theta. I'm not yet put down the final values, but yeah, one more step will be done. When is cosine theta equals to half? Remember, you need to write the answers in two quadrants where it is positive. It's going to be in quadrant 1 and quadrant 4. In quadrant 1, theta is half at pi by 3. And the reference angle in quadrant 4 is pi by 3. Everybody okay? And then you will answer this question: when is cosine theta equals to negative 1? Remember, cosine theta goes from 1 to 0, comes back to negative 1 at pi. Alright, take a look at everything and please ask me questions on any of the steps that's not clear. Everybody okay? Alright, this is the last problem I'll do. I know we have a few more minutes, but we can stop here. We can pick it up next class. Alright, so